Okay, I forgot to mention you can name your magic tricks whatever you want. So maybe this one I think it comes out to 0, so we'll call it the nullifier. But phi, or I think that's right. Anyway, or maybe it's I don't know. It's a funny name, but you can make up any name you want for these tricks, and this one's called the lefty no looker. All right, so now we're gonna do something a little different. Now all these are blank, so we don't know what the next step is, but this is given to us, right? So maybe we can um, kind of break this apart and figure out what are the intermediate steps. So it looks like we have to pick a number first. So let's pick, make it easy. How about 2? Okay, so x is equal to 2. And so what is the last step that was done here? So you kind of have to think of what is all grouped together that is kind of inseparable, and what can I pick off as the last thing. So I think this taking away x was the last thing, and we happen to know that x is equal to 2. So I'm going to go ahead and I know that the last step then was to subtract original number, right? So to undo subtracting that original number, I would have to add add 2 to it, right? So I don't know. So let's see. Let's say I had to add 2 to it, right? Yeah, subtract the original number. So I'd have this set up without that x. So I'm adding x to it. All right. Now, what was the last thing that was done here? It looks like this is all grouped together. So this is kind of the thing that can be picked off, right? This is multiplied by 4. And if I were to undo multiplying by 4, that would be dividing by 4. So I'm going to get rid of it, divide it by 4, and I'm left with x plus 7 over 4 plus 5. Okay. Now, what do you think is kind of grouped together here? I think the 5 is kind of the thing I can pick off, right? So add 5. And to take that off, I'd subtract 5, and I'd be left with that, right? And then now what can I pick off? Remember, the division bar is a group, so everything kind of on top of the division bar or below the division bar is kind of grouped together. So this 4 is kind of hanging by itself. So this is divide the whole thing by 4. And to undo that, I could multiply by 4, so then I'd be left with x plus 7. And then the last thing that's hanging on is that plus 7, so add 7. And to undo that, you would subtract 7, right? So let's see what we end up with at the bottom here. So I add 7, I get a 9. Divide by 4. Oh, this comes out as a fraction, right? 9/4. So it is possible that we end up with kind of funky results, right? And they aren't really funky, they're just different types of numbers. They're rational numbers instead of integers. Okay, so add 5 to it. So what's 9/4 plus 5? 5 is the same as 20/4, right? So I'd have 29/4. And then multiply by 4. Oh, well, that's nice because 29/4 times 4 would just be 29. And then I subtract my original number, which was 2, and I get a 27. Okay, so that's interesting. Now let's go to another one. Now here they don't give us anything. They don't have a starting point. They just have the ending point. So we're going to break this whole equation apart. These two expressions are equivalent to each other. And we're going to find out what was the original number that was picked, right? So let's pick this apart. So the last thing that was done was to add 3. So to undo that, I would subtract 3, and I'd get this expression. And subtract 3 from 13. All right, so think about it this way. I took 10 and I added 3 to it, right? So to undo adding 3, I subtract 3 to get to that 10. Okay, and then the last thing that was done was divide by 4. And so if I undo dividing by 4, this would have been right? If I undo dividing by 4, I multiply by 4. So this would have been 40, right? I take 40 divided by 4, I get 10. Or 10 times 4 is 40. So this expression. And now if I want to undo the last thing here, I can pick off the 5, right? This was multiplied by 5. Multiply 5. So to undo multiplying by 5, I have to divide by 5, right? So this should have been 8, right? 8 times 5 would be 40. So that looks like that. And then the last thing was add 3. And so to undo adding 3 would be to subtract 3. So I subtract 3 from 8 and I get 5. So this would be x. So that means that the person that picked a number actually picked a 5, right? So a lot of times in the world you will end up with something crazy like this, and we want to get back to what is the number that represents this, that makes this actually work out as true. It could be that there are an infinite number of starting points that would have come up with that result. It could be that it's impossible to come up with this result. Or it could have been like they had to have picked 5 to come up with this result. So let's check this. Let's say 5, add 3 to I get 8, multiply by 5 I get 40, divide by 4 I get 10, add 3 I get 13. So that works out. And that's just a way to check our answer. Now let's go back and let's plug in 5 for x in this expression and see, so does it work, right? So 5 plus 3 is 8. 8 times 5 is 40. 40 divided by 4 is 10. 10 plus 3 is 13. See? So that's a way you check your answers. You plug this result back into your original equation. Okay, let's do one more just so we have a lot of different ways to look at it. So the last thing that was done here was to subtract 9. So to undo that, I add 9, right? So 23 plus 9 will be 32. And we add 9 to this side as well to get rid of it. Now the last thing that was done, what's all grouped together and what can I pick off? It looks like the 2, right? So I can multiply by 2. So to undo that, I divide by 2. So 32 divided by 2 is 16. And 2 divided by 2 is 1. So what happens when we divide something? It turns into a 1, right? Divide something by itself. And making a 1 out of something, 1 times anything is just that thing, right? So this is x plus 3 over 7. And now it looks like it was divided by 7. So to undo that, I multiply by 7, right? And 7 divided by 7 is 1 again. So it turns it into a 1 times something, which is just that thing. So 16 times 7 is 42. 7 plus 4 is 11, so 112. Okay, and then looks like we added 3. So to undo adding 3, I subtract 3 and I get to 109. So you can see that you can do a pretty complicated equation just by undoing each step one by one. So maybe when you started, you looked at this and you said, I'll never be able to solve one of these types of equations. But it's not so bad when you take it step by step and you undo a step by step. Okay, so you're going to have a couple more to do on your own and have fun with it.